All right, warm-up number 79 reads, number 1, use -1, 0, 1 to evaluate the functions f of x equals 2 to the x exponent and f of x equals to 10 to the x exponent. Now today I'm doing a soft introduction to what the next concept coming up in a couple of weeks is, which is exponential functions. There it is. And all that's going to tie into logarithms. So I'm giving you a little sample of it with number 1. Number 2 reads, graph f of x equals x cubed and transform according to g of x equals f of x plus 4 over 2, and at the end minus 3. Number 3, rewrite each expression, a to the negative 7 exponent. Part B is 100 to the 0 exponent. Part C is 1/3 in parentheses to the -2 exponent. And number 4, if x to the 3rd times x to the 5th is x to the 8th, then rewrite 2 to the exponent of x plus -3. I'll give you some time for that. And all right, so I'm going to go over number 1 just for the sake of, like I said, it's a preview of where we're going with our main concepts. So number 1 says use -1, 0, and 1 to evaluate the functions. There's 2 functions. How do we evaluate? So here goes a recap on how to evaluate. We rewrite the function, and we just substitute for the value of x. So what is my first value? -1, -1. Okay, so f of -1, can we have a negative exponent? No, so that means we would write this over 1, do the reciprocal, is that correct? So I end up with 1 over 2 to the first exponent, and I'll leave it as is. There you go. Next, f of 0 equals to 2 to the 0 exponent. F of 0. Any number to the 0 exponent is 1. And last but not least, f of 1 equals to 2 to the first power. Anything to the first power is the base itself. What is the base? 2. So, now that I showed you that, see if you can do f of x equals 10 to the x by yourself. All right, let's see, f of -1 is 10 to the -1. If we do that over 1, and f of -1 is the reciprocal and change the power to a positive, so it's 1 over 10 to the 1. Yes? F of 0 equals 10 to the 0 exponent, so f of 0 is, anything to the 0 exponent is 1. F of 1 equals 10 to the first power, so that f of 1 is, anything to the first power is the base itself, so that is 10. Very straightforward, yes? Yes, was it cute? All right, good. All right, let's move on. Number 2. For number 2, we said that this is a parent function, and it looks like this. And what is this point right there that it goes through? 1, 1, yes? Okay. However, they want us to transform it according to this. That means we need to get rid of this denominator by putting a 1 there. So this becomes g of x equals 1/2 f of x plus 4 to the 3rd power minus 3. So we know it's going to go 4 to the left and 3 down. Is that correct? All right, so what's the only thing that we need to worry about? This. What is that going to do to our original function? Tell your neighbor, please. Yeah, by now you should be able to identify that it's going to compress it. So instead of being at 1, 1, that one's going to be at 1 and 1/2. So it's going to do something like this. It's going to become a little bit more compressed. And then we can move it to 4 to the left and 3 down, 4 to the left, 3 down. So it's going to be somewhere over here. All right. 3a, a to the negative 7 is 1 over a to the 7. B, 100 to the 0 exponent is? This one, distribute, that's negative 2, negative 2. We do the reciprocal, that's 3 to the second over 1 to the second, which is 9. So far so good, yes? And last but not least, we have 2 to the x plus negative 3. You should have written before that was 2 to the x times 2 to the negative 3. So far so good? All right, can we leave it as a negative exponent here? No, we do the reciprocal. So this becomes 1 over 2 to the third power times 2 to the x. I'm going to put that over 1 so I can multiply the fractions. Therefore, this is 2 to the x over 2 to the third. What is 2 to the third? 2 times 2 times 2, which is 8, and we have 2 to the x on the numerator. We good? Yeah? All right. So, let's move on. We have plenty to cover today because we're going to finish off the first part of the Module 8 today. Here we go. Our agenda for today, warm-up number 79. Today we're looking at rational functions, and your home plate pages 396, 397 only. 396, 397 only. And those I already uploaded on Canvas, so if you go to Canvas to the rational functions module, they're in there. All right. We good? Yes? Yes, Mr. Q? All right. So, asynchronous code. No asynchronous code. Last night's home plate is free for you guys. Just extra practice. Is that good? Yeah? All right. Thank you, Mr. Q. You're welcome. And tonight's, once again, 396, 397 only. So it's only 2 pages tonight. Yes? All right, let's move on. Get a Cornell note ready. You don't need a prayer model. We're going to move on expeditiously because we need to get to a couple of things today. Make sure that we stay focused. However, today's objective, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. You notice we added a couple more skills to that. We only started with graphing. Today we're going to be writing and solving. So make sure you stay focused throughout. Once again, I can write, solve, and graph rational functions. Make sure you have your colored pens because today we're going to add more processes and you're going to need to keep organization so like that you don't get lost. So once again, I can write, solve, and graph rational functions. We know what rational functions are. That's why we don't need a Freire model. We know that they are equations that contain fractions. We filled that in already for 2 days already, yes? Yes, Mr. Q? From there, I gave you guys steps to graph. Is that correct? Look up. Yes, we have those 3 steps, yes? Which were what? Identify the asymptotes, input-output table, and then graph. Well, look at today. Look up. For graphing today, we're going to do this. Look at yesterday. Look at today. Look at yesterday. Look at today. You're like, oh, I love to do, Mr. Q, long division. Let's go. Copy that step, please, at least. Step number 1, use long division to rewrite the rational function. Use long division to write the rational function, and the rest of the steps are still the same in order to graph. So yeah, today's going to be a bit challenging, but like I said, very doable since we've been doing our practice. Practice? Talking about practice? Yes. Have you guys seen that with Allen Iverson, some of you? Oh. Who's Allen Iverson? You guys know who Allen Iverson is? Huh? What? All right. So this is for graphing. So what is the only thing that we're adding for the graphing portion today? That we need to use long division to rewrite our rational function. That means it's going to be a little bit different than what we've seen. Okay, so that's one thing. The second part of the session, I'm going to give you a graph, already graphed, and you need to write an equation from that. Let me repeat that again. I'm going to give you a graph. You're going to write an equation from that. And that requires a process. So here's the process. In order to write a rational function, you need to, number one, write the general transformation rule of the rational function. 2, identify the vertical and horizontal asymptotes and substitute into the rule. 3, identify a given point and substitute values into the rule. 4, solve for the remaining variable. And 5, rewrite the function and graph. Simple steps. Get your phone out, take a picture, and then you can copy those as we go along. Have those handy so like that we can get to the session. Okay, we got it? So, 5 simple steps. Like I said, you can go writing those as you go along throughout the session. Make sure you have them handy because we're going to get to that towards the end of the session. All right, so, shall we? Here we go. So, where have we been? Well, we talked about the general transformation rule. It went from here to here for our rationals. From there, we talked about asymptotes. We said we're working with vertical and horizontal, yes? And next week we get to the funner ones, which is diagonal, slant, or oblique. And from there we talked about that H is our vertical asymptote and K our horizontal asymptote. We did practice with that and so on and so forth, yes? And then we went and we did some of these yesterday, yes? Okay. And the day before. So before I move on to the next portion, look up to the screen real quick. 2 things. Number 1, commutative property, don't copy this, of addition. I've been talking about this since elementary, and I think they showed you this since you were in 3rd grade, I want to say. The CAD properties, commutative, associative, and distributive. You guys remember these? Commutative comes from the root word commute. Commute means that it's what? It travels back and forth. And in this case, for addition. For example, if I gave you the numbers 3 plus 4, commute means that I can make these numbers travel or move, and the outcome is still the same. 3 plus 4 is the same as 4 plus 3. Can I do that with fractions? Yes. 3 plus 1/2 is the same as what? 1/2 plus 3. Does that make sense? Okay, so that's the first thing that I just want to elaborate on. The second, look up please. We've been graphing rational functions that look like this. I gave you plenty of practice on the warm-ups, is that correct? And what did I say? That this point is always 1, 1, and this one is -1, -1. So far so good, yes? Okay. Now, the reason I'm bringing this up is because of this. Today, when we get to the graphing portion, I'm no longer going to ask you to make a table for all the other points that I asked for here and here. We're only going to use 2 points, one for this side and one for that side. Does that make sense? You're like, okay, the less work? Yes, we got this. Ready? All right. So, clear of that? Okay, copy this. Example 1. And it reads, rewrite the function and graph, identify the domain and range, 3x minus 4 over x minus 1. Rewrite the function and graph, identify the domain and range. G of x equals 3x minus 4 over x minus 1. That's you. Okay. Let me zoom in. Laying utensils down, look up to the screen. Here's a given function. Does this look like the one we've been working with so far this week? No. It looks familiar, but it doesn't look anything like what we've been using. What do we have so far in the first 2 days? That there should be only a number 1 on the numerator. Is that correct? All right. That's why today the first thing we need to do is use long division to rewrite this. So everybody with me? Here we go. Let's write this out as long division. 3x minus 4 divided by x minus 1. Copy that. And let's do this together. I'm going to start with red. What number times x gives me 3x? 3. So let's see. 3 times x is 3x. 3 times negative 1 is negative 3. We're going to subtract. And what does that mean, Mr. Q? That I need to distribute this negative to both of these terms right here. So this becomes negative 3x. And this one changes from negative to positive 3. Now we can do the subtraction. 3x minus 3x, they cancel. And we have negative 4 plus 3 leaves us with what? Negative 1. That's a remainder, yes? Okay, question. How do we write this? Well, our answer is 3 plus what? What's our remainder? Negative 1 over x minus 1. Yes. You're like, okay. All right. Is everybody following up to right there? Yes? So far so good? However, does this look like what we've been working with? Kinda. The only thing, we need to move this one to the end, can we? Yeah, commutative property, yes? So I'm going to point an arrow that I'm going to move it over here, so like that I don't lose track. So therefore, this becomes negative 1 over x minus 1, and then the positive 3, I'm going to move it to the end. Is that looking more like what we've been working with? Yes, Mr. Q. Okay. However, question. Can we have a negative on the numerator? No. Let's bring that to the front. So I'm going to bring this one, move it over here to the front. So this is negative 1 over x minus 1 plus 3. Now this looks like we've been working with, and we're going to set that equal to g of x. All right, just to recap, here it goes. We started with this function, only one fraction. We used long division to rewrite it, commutative property to move the constant to the end, and if this is a negative, we move it, or any factor that is not at 1, we move it to the front. There it is. And now this is our new function. All right, let me zoom out. All right, so we're here. That was step 1. So if I was to ask you to graph that, which is what we've been doing for the past 2 days, what would be the next step? Identify what? The VA and the HA. All right, talk it over to your neighbor. Let them know what the VA is, vertical asymptote, and the horizontal asymptote, according to that equation. All right, good conversations. Let's see, Mel, x equals 1 and y equals 3. That is correct. All right. Now, let's assume that you didn't have this coordinate plane. I'm going to start it from scratch with you. So let's get a coordinate plane going right here. And then we got x equals 1. X equals 1 is right there. And then we got y equals 3. We got 1, 2, 3. All right? You're like, oh, this seems familiar, Mr. Q. Yeah, we've been doing this for a couple of days now. Okay. How are we doing? Yes? All right. Last step, we need a table. So here we go. I want you to make a table over here. We got x, g of x. Now for tonight, look up. We're only going to need one value for each side of the asymptote. So what was my vertical asymptote? 1. So we only need one value from the left and one value from the right. Now let me tell you why. Look up. Why, Mr. Q? Look up. Didn't I just mention that we only have, we're going to focus on this point and this point? Yes. 1, 1 on one side, 1, 1, negative 1, negative 1 on the other. That means we only need 1 point for today. So therefore, what value shall I use for my x values to input onto the function? Talk it over to your neighbor. What values do I use? Yeah, I heard 0. Is that correct? Yeah, 1 from the left and 1 from the right, which would be what? 2. Now, if you want to add more, that's fine. You know, make it a family math night or something. So, let's rewrite this. I'm going to zoom in to do the work. Here it goes. I'm going to write, I'm going to write this right here, negative 1 over parentheses minus 1 plus 3. All right, first value, 0. So, 1, negative right there. Okay, so we have 0 minus 1 is negative 1. Yes? Plus 3. So question, what is negative divided by a negative? Positive. What is 1 over 1? Plus 3. All right, let's do the next one. I know, right? All right, here we go. Negative 1 over and plus 3. Let's see. Next value is 2. What is 2 minus 1? Oh, 1, not bad. Yeah, sorry. 1. I did that on purpose here, paying attention. What is 1 over 1? 1, and it's a negative. So negative 1, yes? Plus 3? 2. And that's all we need to graph our rational function. Here we go. All right. 0, 4. 1, 2, 3, 4. Now going from left to right, they have to be close to the asymptotes. Arrows at the end. 2, 2. 2, 2. From left to right, close to the asymptotes. Arrows at the end. So what's the only thing we added today, guys? That it's not written the way we used to see it. That means we need to do long division, rewrite it using commutative property, make sure you only have a 1 on the numerator, identify the asymptotes, get those down, and use only 1 point for each side of the asymptote, and graph. From 1 to 5, I'll come to body with this. All right, 4, 4, 5, 5, 5, 5. Okay, let's do another one. Copy this one. Example 1Q. We got g of x equals 4x minus 7 over negative 2x plus 4. All right, I'll give you a head start and see how you do for long division. Oh, let me help you out. There you go. Ready and go. All right, let's see where we're at. What number times negative 2x gives me positive 4x? Negative 2, that is correct. Some of you just put positive 2 because you said, oh, it's going to cancel. No, that's what I'm saying. Your brain wants to go ahead of you. Make sure it's the exact same number. So that becomes positive 4x. Negative 2 times 4 is negative 8. We're going to subtract. This is where we distribute this negative to here and change this to its opposite. There it is. These cancel, so we're left with 1. So far so good, yes? Alright, so what was the answer? Negative 2 plus, what was the remainder? 1 over negative 2x plus 4. Can we leave this constant in the front? No, we need to send this to the back. So this becomes 1 over negative 2x plus 4 minus 2, and all that equals 2 g of x. Woo, let's go. We good? Yes? All right. Next, identify our VA, which is x equals 2, and HA, which is y equals 2. Let me give you the easy one. We know that the horizontal asymptote, which is negative 2. Now, how do we find our VA? Look at it. Do you notice that we have a coefficient next to x? So what did we say we do when we have something like that? We set it equal to 0 and we solve. So therefore, minus 4 minus 4, negative 2x equals negative 4, divide by negative 2, x equals 2. So my vertical asymptote is positive 2. All right, so let's plot those on our coordinate plane. We got x equals 2, 1, 2. And we got y equals negative 2. Okay. So far so good, yes? All right. So now we just need our table. We got x and g of x. X, g of x. What two values do I use for my x? Tell your neighbor, please. What two values do we use for x? Yeah, so right away you go to your vertical asymptote. That was 2. That means we're going to use one from the left and one from the right. So that is 1 and 3. All right, let me zoom in to do the work over here. That means I'm going to rewrite this right here. I got 1 over negative 2 parentheses plus 4 minus 2. My first value is 1. So this is 1 over. What is negative 2 times 1? Negative 2 plus 4? 2. So now we have negative 2 and positive 1/2. So this is negative 1.5. Let's do it again now for 3. Let's see. What is negative 2 times 3? Negative 6 plus 4, negative 2. So now we have negative 2 and negative 1/2, so that gives us negative what? 2.5. Yes, that is correct. All right, let me zoom out. So look, we got 1 and negative 1.5. 1. Negative 1.5 is about right there. And we go from left to right. And then 3, negative 2.5. 3, negative 1, 2.5, which is down here. From left to right. There you go. All right, from 1 to 5, how comfortable are you with these? 4, 5, 5, 4s, okay. One more, just for the sake of it. All right, here it goes. Copy this. Example 1 super cube. 3x plus 8. Oh, sorry. 3x plus 8 over x plus 2. 3x plus 8 over x plus 2. I'll give you a head start for the long division. Ready, go. All right. Are you up to right there where I'm at? Yes? All right. Question. Can we have a 2 on the numerator? No. It has to be a what? A 1. However, can we rewrite 2 in our noodle as 2 times 1? Yes? So that means if we leave the 1 there and we move the 2 to the front with a multiplication, this right here, 1 there, it becomes 2 times 1 over x plus 2 plus 3, and all that equal to g of x. Draw arrows, so like that you know what we did here and there. For your notes. All right. So, with that said, say your neighbor the VA and the HA. All right, I heard VA is -2, yes, and the HA is 3. Okay, let me zoom out. So, let's plot those. Is that kind of crooked? A little bit. All right, so you go. It's still crooked, but anyways. 1, 2. Y equals 3. 1, 2, 3. Oh my goodness. Yeah. All right. So, table. We need 2 values. Tell you here are the 2 values for the table. Yeah, -3, -1. This is -2. That means we're going to go 1 to the left to -3 and 1 to the right to -1. All right, so let me zoom in to do the work. You guys hear that pigeon outside? You guys didn't hear it? Anyways, it reminded me of my grandma. Used to say that when they sang like that, they were talking, the pigeons to the other pigeons. All right, first value is -3. So this is 2 times 1 over, and then plus 3. All right, so let's see. What is negative 3 plus 2? Negative 1. So what is 1 over negative 1? Negative 1 times 2. Negative 2 plus 3. 1. Did you guys hear it? Yeah. My grandma used to say that it said, ¿Qué tienes, niño? ¿Quieres tuna? ¿Quieres tuna? You guys know what tuna is? Some of you? In Mexico, we eat a fruit called the prickly pear from the cactus. Have you guys heard of that? Yeah, it's really good. It's like a good. We're like, this is cute. Let's finish this because it looks overwhelming. No, it's not. Negative 1 plus 2. 1. What is 1 over 1? 1 times 2. 2 plus 3, that's 5. Yes? All right, let's plot those. Negative 3 and 1. Negative 3 and 1, which is right there, from left to right. There it is. Negative 1 and 5. Negative 1, 1, 2, 3, 4, 5. From left to right. There you go. All right, from 1 to 5, I'll come to borrow you with this. 5, 5, 5, 4. Okay, that's half of it. And here goes the last one. Ready? Copy this. Let's crank it up a bit. Yes. Copy this one, please. So, follow along. Create a coordinate plane just like mine, from here to here and from here to here. Do you guys see it? Yes. Okay, there they are. Let me make it a little bit thicker so you guys can see it. There it is. And then you're going to create, still kind of crooked. Okay, there it is. Then we have a vertical asymptote going this direction. And that's at negative 2 of x, negative 2. A horizontal asymptote going through at positive 1 of y, positive 1 of y. All right, and then you're going to graph on this side. Just use the point negative 3, negative 3, positive 5, and then you just graph your little curve. And on this side, negative 1, negative 3, and then graph your curve on that side. I'll wait for you. Then write this general rule. I'll give you some time to copy that. Copy and go. It reads, number 2, write the equation of the function given the graph, and they tell us what rule to use. So, it reads, write an equation given the graph. So they give us the graph now. Now we need to write the equation. And they're asking us to use this rule. Okay? So, with that said, I'm going to use the process that I asked you to take a picture of to make sure I follow all the steps. So step 1 says, write the general transformation rule. Did you guys write this already? All right, so step 1 is done. You wrote the rule that they give you, yes? Okay. Step 2, identify the vertical and horizontal asymptote. So what is our VA? X equals what? Negative 2, which is here. And what is our HA? Y equals what? 1. Okay, so write that down. So we got that for step 2. But it says towards the end, substitute into the rule. Okay, so for the vertical asymptote here for H, what am I going to substitute? Negative 2. How about for K? 1. All right, let's rewrite this. So we get G of X equals A times 1 over x plus 2 plus 1. How did I get plus 2? Negative times a negative equals a positive. Okay. We're done with step 2. Step 3. Identify a given point and substitute the values. So which point do you want to use? Negative 3, 5, or negative 1, negative 3? Hurry up, we're running out of time, guys. Alright, so this is our x, and this is our g of x. So I'm going to substitute negative 1 here for x, and negative 3 for g of x. So this becomes negative 3 equals a times 1 over negative 1 plus 2 plus 1. Is it clear that I substitute those values? Yes. Next, solve for the remaining variable. What's the remaining variable, guys? A. So this is negative 3 equals a, 1 over 1 plus 1. How do I get 1? Negative 1 plus 2 is 1. What is 1 over 1? A times 1 is a, equals negative 3. Let's continue solving. Minus 1 minus 1. Negative 4 equals a. Can I write my rule now? Yes, Mr. Q. I'm right here. All I'm going to do is substitute for a, so I end up with g of x equals negative 4 for the a, yes? And then parentheses 1 over x plus 2 plus 1. Tonight's home we're going to have a couple of these. Make sure, follow the process. Also some of the other ones with the graphing. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.